All right. Good day, my viewers. I'm Uncle Frank Okafor, the proprietor of Phrankstars Classic School, Amoga in Anambra State. I want to take this series. We've solved some past questions, but we want to concentrate more on releasing series from time to time. Now we'll be taking simultaneous equations, the series, meaning that in the next few weeks, all our videos and teachings will be around questions that relate to simultaneous equations. But today, I would like to focus on explaining some important concepts we need to understand very well before we can go to solving standard exam questions. So today I'll assume you've not heard about simultaneous equation. So even if you've heard about it before, you've learned how to solve it to some extent, I want to implore you to take your time, listen to what I will say. Of course, you definitely will hear something new you've never heard before, and of course you will definitely improve your knowledge base when it comes to this topic. All right. Simultaneous equation has to do with two linear equations that have the same values of the unknown being the same, or the values of the unknown being the same for the two of them. So if I talk about simultaneous, that means the two of them are the same by the values of the unknowns they possess. So it's not a big thing. I hear some people, when they want to crack jokes, they say this thing is like simultaneous equation. This thing is as hard as simultaneous. No, simultaneous equation is not hard. It's just an understanding that you have two linear equations that share the same pair of unknown. Meaning that if I have, for example, question number 1, if I have 2x plus 3y is equals to 8, and x minus 3y is equals to minus 5. I can easily say that I am sure if these two equations are simultaneous, that means the value of s and the value of s will be the same. And of course, the value of y and the value of y will be the same. So meaning that if I solve and get x to be 5 and y to be 3, I can easily say that I'm sure that this particular x is 5 and this one is 3. That's just the concept of simultaneous equation, where we know that these unknowns, if they are simultaneous equation, that these two unknowns are what? The same. All right. So we can solve using substitution, and the elimination. So there are two ways of approaching simultaneous equation. We can even solve graphically. Of course, we can solve graphically, but we can even solve using matrix method. But for clarity, I want to concentrate on either the substitution or the elimination. First of all, I want to do elimination for now. Then subsequently, when we've mastered this method, we can introduce our elimination. So we assume that we are not substituting for now. So we don't mix up the two concepts. So the concept we want to work with now will be the elimination concept of simultaneous equations. So now, to eliminate, always tell them I said, to eliminate, there are two important conditions that must be met for elimination to take place. And once you meet them, the elimination is possible and easy. The two conditions would be that the signs of the number you want to eliminate or the unknown you want to eliminate will be what? Opposite in nature, meaning if one is plus, one must be minus. Then again, the coefficient of the unknown, coefficient is the number. For example, if I say 6m, the coefficient of m is what? 6. So for simplicity's sake, we can simply say, for us to eliminate, remember, to eliminate something means to remove it. So what we want to do is to remove one of the unknowns, keep it aside, solve for the other one, get it, then put it back. to get the one we removed. So in elimination, we are just trying to remove one of the unknowns, keep it aside, then solve for the other ones, then get it and put it back to get the value of the one we removed initially. So in that case, we simply say if the signs are opposite and the coefficients are equal, then we have achieved what? We have achieved what? The conditions. So for these conditions to be correct or to be met, the signs must be opposite and the what? The coefficients must be what? Equal. Looking at this, the sign here is plus, the sign here is minus. 3 is here, 3 is here. That means the condition is what? Met. So we can simply simplify. So in this case, we can call this equation 1, equation 2. To eliminate, I can simply say, once this and this are the same. Notice what I said now. Once the two conditions are met. Remember the two conditions are what? Signs must be opposite, coefficients must be what? Equal. So in that case, this is this and this is minus. This is 3 and 3. That means the two conditions are met. What do? We do what? Add. So I can simply say, once the conditions are met from the original equation, you just say equation 1 plus equation 2. So this is the lowest level we can say. So I'm adding now equation 1 plus equation 2. So I'll say, let this be my equation 2. I'm adding 2x plus s gives us what? 3x. Plus 3y plus minus 3y gives us what? 0. That's the elimination now. So we've taken it out. Remember, we say elimination is trying to remove it. So plus 3 minus 3 gives us what? 0. This plus this gives us what? 3. That is 8 minus plus minus 5 gives us 3. Meaning that s is equals to 3 over 3, which gives us 1. Then I can now impute the value of s in any of the equations. So we can say put x equals to 1 in the equation 1. So x is 1. So I can simply say 2 times 1 plus 3y is equals to 8. So I can say 2 plus 3y is equals to 8, meaning that 3y is equals to 8 minus 2. Y is equals to 6. So, sorry, 3y is equals to 6, meaning that y is equal to 6 over 3, which is 2. Of course, you can rewind this video. There's always a new opportunity to do something better. There's always a new opportunity to do something better. So even if you've never understood simultaneous equation concept, I promise you, if you follow this series to the end, you will definitely learn something new. All right, we take the second example. The second example says, remember, we are treating the concept of elimination. We kept substitution for now. Of course, we might not really be able to efficiently treat graphical method on the board, and maybe metrics might bring confusion. So I want to concentrate on elimination and subsequently substitution. So the metrics and the graphical method, we might not really do it on air. All right. So we take the next question. Example number 2 says 4m plus 2m is equals to 6. M plus 2n is equals to 0. Notice now that we have a situation where plus and 2 and 2. One of the conditions met, but the other one not met. We said the two conditions, remember, are that the signs must be what? Opposite, and the coefficient must be what? Equal. So in this case, we have plus and plus. It's not true. Then 2 and 2, meaning that one condition met, one is not met. Now we have a plus and plus. Now remember, we said that a negative sign in front of a bracket changes this signs in the bracket to the opposite. So we adopt that concept now to change this one, because we want to make sure that we have plus and minus. Remember, we said the two conditions for elimination will be equal coefficients and opposite signs. Now we have the same sign. So whenever you have the same sign, remember we say whenever you have plus and plus, what do? Simply do what? Add. Sorry, whenever you have plus and minus, simply do what? Add. But when you have plus and plus, or plus and minus and minus, you do what? You adopt the effect of the negative sign to change it. So in this case, I can simply say this is my equation 1, this is my equation 2. So I can say equation 2 minus, or let me say equation 1 minus 2. Of course, you know, any one you choose, 2 minus 1, 1 minus 2 will give you the same answer. It's just a careful, if you solve it carefully, you will definitely get the same answer. So in this case, I simply say equation 1 minus 2. Meaning that if I want to introduce my sign, that is this minus sign, this is my equation 1, of course. This is my equation 1. This is my equation 2. Meaning that 1 is this minus equation 2. Look at what I did now. Equation 1 minus equation 2. So we have 4m minus m will give us 3m. 2m minus plus. Minus plus is what? Minus. So we have 2m minus. This minus will change this one to minus, which is what we targeted. So we have 2m minus 2m, 0. Our target of elimination achieved. So we have 0 gone, m is gone, 2m minus 2n. Sorry, this should be n. Sorry. So we have 2n minus 2n is 0. 6 minus 0 is what? 6. So in this case, we have that m is equal to 6 over 3, which gives us what? 2. We now put m equals to 2 in any of the equations. Let me choose equation 2. Equation 2 is this now. So my m is what? 2 plus 2n is equals to 0. Meaning that we have 2n is equals to minus 2. That is 0 minus 2. Remember, this is a plus 2. Comes to this side becomes minus 2. So 0 minus 2. Then we have n is equals to minus 2 over 2, which is what? Minus 1. Of course, when you substitute these values in this equation, it should be the same. All right. Thank you, and God bless you.